Shana, can you hear me?
Yeah.
Can you go through the case 3?
Okay. So, case 3 begins with 1 1 1 2. Wait, let me just draw the chart again.
Yeah, sure.
Uh, okay. So since no twos can be, we have to do the same thing as before. The twos can't be next to each other, so we have to count the number of possibilities for the twos. So we can't put a 2 here, so then we'll put a 2 here and here or here and the last one, or we
Yeah.
can start here and put a 2 here and here, but we can't put a 2 here again because then you have to put a 2 here, but there's not enough space for that.
Yeah.
So there's 3 possibilities to place the 2's.
Yes.
So once you have the
It would be
2's,
really easy if you name the positions like 1, 2, 3 like that. So here you do have 6 and 8, 6 and 9, 7 and 9, right? So that would be very easy for you to finish the calculation faster. Now you don't have to do it. I'm just telling you, you keep the strategy in your mind. During the exam, you can go for this because they gave you the condition that two consecutive twos are not possible. So they might
yeah,
also give you you shouldn't put maybe three twos together or two twos in the third and first position. Sometimes they might specify the positions also. So in that case, this helps. If you name them, it would be really easy for you to do it.
okay. So um, so there's 3 possible pairs for the 2's, and 3 possible positions. And then once you have the 2's, you don't need to place the 1's this time because you already put all 3 1's over here. So the next numbers we have to place are 3 and 4. So again, it's going to be the same 2 positions. You can put the 3 first, you have to put the 3 first, then you can go 3 3 4 or 3 4 3. So then you have the 3 possible pairs from the 2's, and
Yeah.
then you have 2 possible pairs for
From
the
3 and
3's
4.
and 4.
Yeah.
So in total, there's 6 possible if you have the beginning numbers 1, 1, and 2. So then
Yes.
all together, we have 200 for the first case, 48 for the second case, and 6 for the last case. So if we add them, we get 254.
54 possibilities. Yes. Yes. Very good.
Yeah.
Okay, what kind of difficulties you were facing before the class when you saw this question?
Well, when I started this question, I didn't know how to do I didn't think of doing the case
Okay,
ones and case
okay,
twos.
okay, okay. That was the issue.
I
But you
just
are
thought
very
it was too
comfortable
many.
with those boxes, right?
Yeah.
Yeah. Okay. Okay. What else you said? You have doubt on the question number 25 also?
Yeah,
Yeah.
24 and 25.
Oh, 24 also. All right. 1 minute. We'll just take a look at the solution, length of the solution, because we are also running out of time. We'll go for the smaller one. I think the 24 is pretty easy, I guess, because they are using the Pythagorean 1 minute. Okay, we'll go for the 24th one. 24th one, it is bit lengthy, but they are using only Pythagorean. So I'll explain how to do it. You might be able to figure it out by yourself.
Okay.
All right. So here you have a cube with the vertices F, G, H, J, K, L, M, N, has the edge length 200. You know what is edge length, right? This is edge length. So this will give you 200. So another edge length, this is also 200 like that, right? So point P is on HG as shown. So over here, the shortest distance from the G to the point inside PFM. This is PFM. The shortest distance from the G to a point inside PFM is 100. Okay. Okay. So you're just traveling from G to a point inside PFM. They mentioned the distance, it takes 100, but they didn't mention the exact point here. So the question is, which of the following is closest to the length of HP? Okay. Which of the following is closest to the length of HP? So you are going to approach from here. Okay, let's see that. Okay. All right. So they are assuming the GP as X. Since the edge length of the cube is 200, HP is 200 minus X. Okay, I'll show you how. So we know this already. This
So
H
GP
to
is
G
X.
is going to take 200. If you assume this part as X, this part is going to be 200 minus X. Because when you add 200 minus X and X together, this positive X and negative X will cancel out each other. You'll be left with 200. So that is how. You can follow this, right? All right. So we consider the tetrahedron, which is a triangle based pyramid. The another name for the triangle based pyramid is tetrahedron. Okay. So FGMP and calculate its volume in two different ways. Okay. So volume of these information you need to by heart. Okay. The volume of the tetrahedron is equal to 1/3 times of the areas of its triangular base times the length of its perpendicular height. This you need to by heart. I'll just underline the FGMP. I'll just see whether I'll be able to copy this diagram as well. I think I won't be able to copy it. Yeah, I couldn't copy the diagram. Okay. FGMP. They're asking about this. Okay, this is FGMP. So FGMP having the base, triangle FGM and height GP. Have a look at FGM. So they're saying that this is the base. Can you see the tetrahedron? Could you please draw the tetrahedron over this? Can you shade it?
Okay.
Yeah.
That's it.
Yes. Very good. So this is your tetrahedron. So they also said this has triangular base, right? Yes, yes, I got it. I got it. So this is going to be your triangular base, and this is going to be your height of the tetrahedron. Can you follow that?
Yeah.
So FGM is going to be the base, which is a triangle. GP is going to be height. So we already knew this height will be always perpendicular to the base. Okay. And FGM is the right angled triangle. Please look at the diagram one more time. FGM. So here you have 90-degree.
Yeah.
So G, it is right angled at G. So from there, they're saying that FGGM is equal to 200. They are just showing the edges. FG is 200. GM is also 200. Okay.
Yeah.
So they are just equating it. They're equating FG and GM is equal to 200. So you're just going to calculate the area. This is very simple formula for calculating the area of the triangle. It's just going to be half into base into height, isn't it? So
Yeah.
you just have to substitute the value of base and height over here, which is going to be 200 times 200. So if you cut this, you will have 100 into 200, which will give you 20,000.
Yeah.
All right. And also, from this information, they said volume of the tetrahedron is equal to 1/3 times of the area of its triangular base times the length of its perpendicular. So you are just going to multiply this by 1/3 times of the area of its triangular. So area of the triangular is 20,000. That also you are substituting. Okay. Base times the length of its perpendicular height. So what is the perpendicular height? We know the perpendicular height is GP and GP is X. So which is why you're having X here. Can you follow this?
Yeah.
Okay. So then you're considering the tetrahedron FGMP having the base as PFM. Let me shade that, PFM. So they are assuming this as the base now.
Yeah.
This as the base now. Now again, they're going to repeat the same.
And then once they find the area,
Yeah.
they're going to make it equal so that you can solve for X.
Yes. And over here, in our question, they're asking us to find the shortest distance from the G to a point inside the triangle, right? And they also gave us the clue that it is 100. The PFM is 100, right? So you're going to use that. The shortest distance from G to a point inside the triangle is 100. This means that height of the tetrahedron FGMP, when we consider to have a base PFM, is 100. This is just an information which is written from the question. This is just a given information. Okay. So we need to calculate the area of the PFM. So how do you calculate that? So they are calculating this because PFM is not a right angle triangle. It is an isosceles one. Okay.
Yeah.
So 1 minute. So they also gave us the diagram for the PFM.
So then we need to find the height.
Yes, yes, yes. So they're saying that PT is perpendicular to FM. Okay. So now you would be able to see two right angle triangles here. So, okay. So they're saying that FGM is right angled at G and FGP is right angled at G. For FGM, FM is greater than 0, which means it is positive. FP is also greater than 0. You're just going to use the Pythagorean theorem for this right angled triangle. Let me draw FGM and FGP. FGM to be 1 minute. FGM and FGP. This is FGM. This is FGM. And you have FGP. So FGP is this. You can see it, right?
Yeah.
Here you have a right angle triangle. And you know this theorem, right? Hypotenuse the whole square is equal to the sum of the adjacent square and opposite
Yeah,
sides.
I know that.
Yes, you're just going to use that. So if you use that, you will have Fm is equal to square root of fg square plus gm square. You're just substituting their values. You know fg and gm are simply the edges. So which is 200. 200 square, 200 square. So which will give you 200 times square root of 2. This is just a simple calculation. Okay. So FGP is right angled at G again. So FP is also has to be FG square plus GP square. You know how. These are all very simple calculation. So we don't know the value of GP. You are just assuming that as X square. Okay.
Yeah.
So this is going to be X square plus 40,000. So they are doing the same for the MP as well. MP as well. If you do the same for MP, you will have the same answer because FP and MP are equal. I'll show you. MP and FP.
Yeah. So then we can find the base of the triangle now.
Yeah. See, because it is an isosceles triangle, right? In the isosceles triangle, you know the property. Two sides are equal, right? So
Yeah.
you are
So then
using
the
that.
base.
Yes.
You can use the
So
Pythagoras
T,
theorem.
yes. T is the midpoint of the FM here. So what do you mean by midpoint? Which divides a thing into two equal parts, right? So you are assuming you're just going to divide this by 2.
Yeah.
FM is 200 of square root 2. So FT has to be 200 square root of 2 by 2. So which will give you 100 root 2. Same
Yeah.
applies for the TM as well, right? So we found this and this. So you are applying Pythagorean theorem over this. PT is equal to square root of FP square minus FT square. You know this, right? Like here you have a right angle and this should be
And they're
hypotenuse.
finding the volume.
Yeah. So you're just substituting their values. You're just substituting the value of FP and FT. So when you substitute and simplify, you will get square root of x square plus 20,000. I'm not showing you the calculation. These are all very basics. So for the triangle, for finding the area of a triangle PFM, you know the formula already. It's just half into base and height. So this is also very simple. So it has to be half times FM times PT, right?
Yeah.
So it's half times, what is FM? FM is 200 square root of 2 and PT, we just got this, so that you have to substitute here. So if you make the calculation, this 2 and 200 will cancel out each other, you will have 100. Okay, they didn't simplify it. They are just keeping it as it is. And then now they're going to find the value of the, volume of the tetrahedron FGMP again. So we already know it's going to be 1/3 of the triangular area of the base into the perpendicular height, right? So you're just multiplying them 1/3 times this into 100.
And then the other side.
Then, you said, as you said
make
earlier, you will just have to equate those two expressions. You already found the volume of the tetrahedron earlier. So you just have to equate them. There is here, the volume of the FGMP, right? So you just have to equate them. So when you equate,
you get x squared equals 20,000.
Yeah. Then you take a square root.
Equal to about 59.
Yeah. So you are getting 20,000. If you take square root, you're going to get 100 times root 2, right? So you just have to substitute that. The question is to find HP, right? So for finding the HP, it's 200 minus 100 root 2.
Yeah.
The value of root 2 is 1.414. Okay. So you just have to multiply that with 100 because here you need to make the substitution because the choices are so close up. You have 53, 56 like that, right? So you need to make the substitution in the root 2. Okay.
Yeah, I think for this test you get calculators. You can use calculators.
Oh, that's nice. That's nice. So you just multiply that with the 100. You subtract it with the 200. You will get 58.58, which could be rounded off to 59. So this is
Yes.
closest to 59. Then the answer is D.
Mhm.
59. See, they are very close. 57, 61, they gave that option. Sometimes in the exam, they'll give you, for root 2, you have to use these many digits. Sometimes they'll also give you 7 to 8 digits. In such case, you have to use the same digits, okay? Because you should not, simply put 1.414. If they are giving you 9 or 10 digits in the question, you got to use the same number of digits in the calculator.
Yeah.
All right. Okay. Okay, Shana, shall we discuss this question in the next class? My father is
Yeah.
going to come down actually.
Yeah. Okay. Bye.
Yes,
Thank
Shana.
you.
Thank you. Thank you. You don't
Oh,
have any doubts, right?
I just want to ask if you could send me the recordings for the last 3 classes.
Yeah. Sure. I'll send you that. Tomorrow I'll send it.
Okay.
Yeah.
Bye. Thank you.
Bye-bye. Thank you, dear. Bye. Have a happy weekend.
You too.
Thanks.